Hello students, today our topic is Chebyshev's inequality. This has a great utility in the probability distribution since this can be used for all the probabilities distribution in which mean and variance can be defined. So here the statement first. Let capital X be a random variable having finite mean small m and variance sigma square, and epsilon greater than 0 be arbitrary small. Epsilon must be positive, that is greater than 0. Then probability of modulus of x minus m greater equals to epsilon is less than equals to sigma square by epsilon square. Or this can be written as, this is greater equals to, we write this as 1 minus probability of mod x minus m strictly less than epsilon is less than equals to sigma square by epsilon square. Or this also be written as probability of mod x minus m strictly less than epsilon is greater equals to 1 minus sigma square by epsilon square. That's the continuous case. Let capital X be continuous random variable having PDF fx. Then sigma square, which is the variance, that means equals to E of x minus m the whole square, where m the mean and E called as expectation. That is integration over minus infinity to infinity small x minus m the whole square into fx dx, where fx is the PDF of capital X. That is minus infinity to infinity, the limiting value. We can be written as integration over mod x minus m greater equals to epsilon into x minus m the whole square into fx dx plus integration over modulus x minus m less than epsilon into x minus m the whole square fx dx. This is x minus m greater equals to epsilon. This is x minus m less than epsilon. That is, it covered all the area, that is minus infinity to infinity. Okay. So sigma square is greater equals to this must, since this is equals to the sum of this, then sigma square is must be greater than one of this, that is sigma square greater equals to integration over x minus m the whole square fx dx on the limit x minus m mod greater equals to epsilon, implies sigma square greater equals to integration x minus m modulus greater equals to epsilon. We can put the value of x minus m the whole square, that is epsilon square, since x minus m greater equals to epsilon. So the least value of x minus m is epsilon, and sigma square must be greater than or equal to with respect to the least value. So we put the value of x minus m as epsilon. The epsilon square into fx dx implies sigma square by epsilon square greater equals to integration over x minus m mod greater equals to epsilon fx dx. That is number 1. Again, we know that probability of x minus m greater equals to epsilon implies integration equals to integration mod x minus m greater equals to epsilon into fx dx. That is 2. So from 1 and 2 we can say probability of this is less than equals to sigma square by epsilon square. That is the Chebyshev's inequality. For discrete case, we can write the integration as summation, that is summation. Then the proof is also completed. Okay. Here we have some problems on Chebyshev inequality. Number 1. So, by Chebyshev inequality that in 2000 throws with a coin, the probability that the number of heads lies between 900 and 1100 is at least 19 by 20. Okay. So, in the question 2000 throws with a coin, that means this is binomial distribution. Okay. So, let capital X denotes the number of heads. Clearly, according to the question, X is binomial. So, here, so small p, probability of getting head, that is success, equals to half, and probability of getting tails, that is failure, equals to half. So, mean equals to, for a binomial distribution, we know that n into p, where n is 2000, okay, and p equals to half, that is 1000. And sigma square equals to var x, that is n into p into q, that is this, equals to 500. Now, the required probability, we have the number of heads lies between 900 and 1100, that is probability of 900 and 1100, x lies between. We use this way. We subtract 1000 both three parts, that is probability of this equals to minus 100 less than x minus 1000 less than 100. This can be written as this way. Okay, probability of modulus x minus 1000 less than 100. Since we know that mod of x minus m less than epsilon, that means minus epsilon less than x minus m less than epsilon. This can be written as this. So, we write this way. Now, from Chebyshev inequality, we have p of this, that is mod of x minus 1000 less than 100 is greater equals to 1 minus sigma square by epsilon square. Okay, sigma square by epsilon square. Here sigma square equals to 500, that is 500, and epsilon means 100, that is 100 square, equals to 1 minus 1 by 20, that is 1920. So, probability of mod x minus 1000 is less than 100 is greater equals to 1920. So, at least value is 19 by 20. Problem number 2. Verify Chebyshev inequality for the distribution of a random variable capital X given by p of x equals to minus 1 equals to 1 by 8, probability of x equals to 0 equals to 3 by 4, and probability of x minus 1 equals to 1 by 8. Verify. That is, we use the Chebyshev inequality formula. At first, we find the mean, that is e of x equals to summation over I equals to minus 1 to 1, that is x valid from minus 1 to 1, that is minus 1, 0 and 1. And according to the question, this is must be the discrete distribution, okay, discrete random variable. So, xi into fi or f of xi equals to x is minus 1, x is 0 and x is 1, and the f of xi are 1 by 8, 3 by 4 and 1 by 8. So, minus 1 into 1 by 8 plus 0 into 3 by 4 plus 1 into 1 by 8. The value is 0. Again, we find e of x square. To find out the var x, e of x square equals to summation over I equals to minus 1 to 1 xi square f of xy equals to minus 1 square into 1 by 8 plus 0 square into 3 by 4 plus 1 square into 1 by 8, that is 2 by 8 equals to 1 by 4. So, var x equals to e of x square minus e of x the whole square equals to 1 by 4 minus 0 the whole square, that is 1 by 4. Now, from Chebyshev inequality, we have the formula probability of mod x minus m greater or equals to epsilon is less than equals to sigma square by epsilon square. That is probability of mean equals to 0, we have already get, and sigma square equals to 1 by 4. Putting the value of those, probability of x minus 0 greater or equals to epsilon less than equals to 1 by 4 epsilon square. That is probability of mod x greater or equals to epsilon less than equals to 1 by 4 epsilon square. Now we have two cases for epsilon, and we know that epsilon is greater than 0 arbitrarily small and must be less than or equals to 1. Okay. Epsilon lies between 0 to 1. So case 1, probability of mod x greater or equals to epsilon. Actually we try to find that probability of mod x greater or equals to epsilon is less than or equals to 1 by 4 epsilon square. So that is equals to minus epsilon greater or equals to x greater or equals to epsilon. That is minus epsilon greater or equals to x. That means x less than or equals to minus epsilon plus probability of x greater or equals to epsilon. That is equals to capital X is less than equals to minus epsilon when epsilon less than equals to 1. That is only valid for x equals to minus 1, since this is the least value. So probability of x equals to minus 1 plus x greater or equals to epsilon. That is x is greater or equals to 1. That is only value x equals to 1. 1 is the most value. So this is 1 by 8 plus 1 by 8 equals to 1 by 4. This must be less than equals to 1 by 4 epsilon square, as 0 less than epsilon less than equals to 1. Okay. So Chebyshev inequality holds for case 1. Now case 2, when epsilon is greater than 1. Okay. So probability of mod x greater or equals to epsilon equals to same as it is, we can write, but here epsilon greater than 1. This is an impossible event. Okay. So this is also be 0, this is also be 0, equals to 0, which is less than 1 by 4 epsilon square, as epsilon greater than 1. So Chebyshev inequality holds for case 2 also. Here it is complete the proof. Question number 3. Suppose the average score on a math test is an 84 with standard deviation of 4 points. According to Chebyshev's theorem, at least 40% of the test have a grade of at least 72 and at most 96. That is, we choose the random variable capital X between 72 and 96. So let capital X denotes the grade of math test. Here in the question given that mean small m equals to 84 and standard deviation sigma equals to 4. So variance is sigma square equals to 60. Okay. Now required probability of 72 less than x less than 96. That is x lies between 72 and 96. Same as previous problems we have done. Subtract the mean. Subtract 84 in 3 each parts. Okay. Then we get probability of minus 12 less than x minus 84 less than 12. That is mod of x minus 84 is less than 12. Now using Chebyshev's inequality, we have probability of mod x minus 84 less than 12 is greater or equals to 1 minus sigma square by epsilon square. Sigma square means var x, that is 16. Okay, that is 16 divided by epsilon means 12, that is 12 square, that is 1 minus 16 by 144, that is finally 8 by 9. So the required percentage is 8 by 9 into 100, that is 88.89%. This is the answer. Thank you.